Okay, so this video is going to be on the properties of logs, review of the properties of logs. Okay, so take a minute, pause the video, try this one on your own, and then come back. Okay, welcome back. So remember, the logs need to have the same base for me to combine them, okay? And remember, the natural log is just equal to log base e. Okay, so I know that these have the same base, so I know I can combine them. And remember, when I'm adding, I multiply my arguments. Okay, so for this one, we have natural log of 3 times x plus 5 is equal to 4. Okay, I'm going to simplify this by doing natural log of 3x plus 15. So I just distributed in there. Okay, now I'm going to utilize this to rewrite my natural log. So I have the natural log is equal to the log base of e of 3x plus 15 is equal to 4. Now I'm doing that, so now I can use my log snail. So I'm going from a log to an exponential, so I always start with my base. So I have e here. Now I make my log snail. Go to here, make my snail. Okay, the next thing that it touches is this 4 here. So it's e to the 4th. And then this is going to be equal to 3x plus 15. Okay, now I'm just going to solve for x. So I'm going to subtract 15. We have e to the 4 minus 15 equal to 3x. Divide by 3, divide by 3. Okay, then this gives me e to the 4 minus 15 over 3 is equal to x. Okay, so the last thing, since we started with a log, we need to double check that we don't have any extraneous solutions. Okay, so there's two ways we could do this. We could either take this number and plug it into our calculator right there, and then make sure we don't have a extraneous solution. Okay, but a little easier way is let's try to reason with these numbers here. Okay, e to the 4th, so remember e is a adjusted number. E to the 4th, if you plug that into your calculator, it's a big number. It's going to be a lot bigger than 15. Okay, so I know when I subtract these two, I'm going to get a positive number. And then when I divide by a positive number, that doesn't change the sign. So I know this is a positive number. Well, when I add a positive number to another positive number, I get a positive. Okay, so I know that this is not an extraneous solution. So I know that's my answer right there. Okay, so we're going to do one more. We're going to do the log base 7 of 9x plus 27 minus the log base 7 of 3 is equal to 2. So take a minute, pause the video, try this one on your own, and then come back. Okay, welcome back. So the first thing I notice is that my bases are the same. So I know I can combine these. I'm subtracting, so that means I divide my arguments here. So I'm going to do log 7 9x plus 27 divided by 3 is equal to 2. Okay, I'm going to simplify what's in my parentheses here. So I'm going to get log base 7. I can simplify this to 3x plus 9 by dividing each term by 3. That's equal to 2. Okay, now I can use my log snail. So I'm going from a log to an exponential. I always start with my base. I go to here to here. Okay, this becomes 7 squared. It's equal to 3x plus 9. 49 is equal to 3x plus 9. Divide by 9, or subtract by 9, sorry. We get 40 is equal to 3x Now we divide by 3. Divide by 3. We get 40 over 3 is equal to x as our answer there. Okay, now we need to check that it's not an extraneous solution, so we plug it back into our original. Well, here has no x's, right? So we don't plug anything in here. For this one, we have log 7 of 9x plus 27. Okay, let's check to make sure our answer doesn't make this negative. Well, if we do 9 times 40 over 3, plus 27. Well, this is a positive number, this is a positive number, so I know my whole thing is going to be positive, so I know this is not an extraneous solution. So that's my answer.